Okay, welcome to the deep dive. So, if you're serious about staking Ether on Ethereum, you know the pressure, right? Keeping your validator online always
Hmm.
and running your key on just one node, well, that creates that classic single point of failure.
Right.
If that node goes down, internet blip, hardware fail, whatever you risk, missing rewards, not making
Or
attestations,
worse.
or worse, yeah, getting penalized, like slashed,
Yeah. Oh, yeah.
losing actual Ether. It's a constant tightrope walk.
It really is. That sort of low-level anxiety, just checking if your validator is still humming along, knowing one hiccup can cost you.
Hmm.
The sources we're diving into today, they introduce tech specifically for this problem, SSV.network.
Right.
It's built on something called Secret Shared Validator, SSV tech, or more broadly, Distributed Validator Technology, DVT.
Okay, so Secret Shared Validator, DVT. What's the core idea here based on the material? How does it get around that single point of failure?
Yep.
Well, what's really interesting is how it changes the whole setup. Instead of that one single, very sensitive validator key sitting on one machine,
Hmm.
this tech provides like an infrastructure to take that key and actually split it into multiple pieces.
Split it.
Yeah, think of them as key fragments, or what the sources call KeyShares.
KeyShares, got it. Okay, so you break the key into parts.
Exactly. And the really clever part is you distribute these key shares across multiple different machines, different nodes, run by different people or entities. And crucially, these operators, the ones running the nodes, they don't need to trust each other. They can, like, collectively operate your validator using these distributed shares, coordinating things. But no single node ever holds the full key.
Huh. That sounds, it sounds almost counterintuitive at first. You're splitting the key, sending pieces off. How does that actually increase reliability or security? Seems like it could add more risk points. Yeah, I see why you think that. But that's where the redundancy and security design comes in. Let's talk reliability first.
Yeah.
Because your validator's jobs, like proposing blocks, making attestations, they're managed collaboratively by a group of these operators using their key shares. If one or even a couple of those nodes goes offline for whatever reason, the remaining ones, if they hold enough shares between them, they can just pick up the slack, keep it going.
Oh, right.
That's what they call active redundancy. So your validator stays online, keeps doing its job. It dramatically cuts the risk of missing attestations or getting slashed. You lose that single machine dependency.
Right. Okay. The fault tolerance makes sense then. If one piece fails, the others cover.
Yeah.
But what about the key itself? Is splitting it like leaving bits of your house key scattered around?
That's a really critical security point the sources highlight. With this SSV or DVT approach, your original validator key, the full one, it can be generated, then split into those key shares, and then that original key, you can store it securely offline. Take it completely out of the picture for day-to-day operations.
Offline? So the operators don't even have it.
Nope. They only ever get and use the key shares. This is the whole non-custodial aspect.
Yeah.
You keep ultimate control and custody of your core key. You're not handing your private key over to some third party to run your validator on their server.
Yeah.
You distribute pieces, yeah, but the main secret stays safe with you.
Okay. Okay. So main key, safe offline. Multiple independent operators use these derived shares, work together, keep the validator running, earning rewards. This structure, it also feels like it really ties into the bigger picture, like network health. Am I reading that right?
Absolutely, yeah. That's a huge part of it. By design, the SSV.network encourages and relies on independent operators globally.
Hmm.
So as a staker, you can pick like a diverse set of operators, different software clients, different hardware setups, different locations, baby.
Right.
And that's not just good for your validator's resilience, avoiding reliance on one single entity. That diversity across the whole network of validators using DVT. It makes Ethereum itself stronger, more decentralized. It helps avoid reliance on just a few massive staking pools or infrastructure providers, which, could become central points of failure for the whole network if something went wrong.
Hmm. So let's try and wrap this up then. What does this all mean for you, the listener? Maybe you're a staker or just interested in where Ethereum's going. It really seems like SSVDVT, by splitting and distributing that key across multiple independent, non-trusting nodes, it directly tackles those core challenges:
Right.
reliability, security, and even centralization.
Exactly.
The ones that come with just running on a single node. It's like building a much more resilient foundation for participating in staking.
Precisely. It takes that inherent risk of concentrating control in one place and spreads it out intelligently, which, helps the individual staker and the network overall.
Okay, so here's something to maybe chew on after this deep dive. How might this fundamental idea, splitting and distributing critical control, like these validator keys, how might that reshape the way we build and secure other kinds of decentralized systems, beyond just staking? what else could this apply to in the future?